Okay, example 5. This is the chemical reaction data, all right? Calculate the equation of the regression line and determine the values of y when x is 3.5 and x when y is 7. Now, I think it will be useful for us to go through the exercise. How do we find the regression line? Now, before we do that, can we first identify? Of course, can I have attention, please? This context is assuming it has been explained what is x and y, and you are able to tell me that x is the independent variable, because x is the time. So, in this case, x is the independent variable. Alright? And the regression line of, we will y on x because, y on x. Now we are about to learn how to use the GC. Using GC, we are not about to use the long formula yet. Okay, we will use GC. GC will help us do everything to calculate the value of B and A. Okay, to know what is the regression line. So, let's do this. Now, just now you already, if you have not done anything to your GC, you will be able to see this. Remember, just now when we calculated R, remember? Did we see this screen? Remember or not? Okay, so that you have your A, you have a B, and that's it. That's your A and B. That is your regression line. You know what I'm saying? Okay, can I go through one more time? Stats. Calculate. And you go to number 4, linear regression. AX plus B. Go to number 4. Then this is the part that I want to explain. The X list is the one that you are going to input into as your independent variable, your horizontal axis. You know what I'm saying? The Y list is the one that you want on your vertical axis, your Y list. So just now we entered 1, 2, 3, 4, 5 into L1. So we use L1 here. Okay? The order is important. Yes. Where is A plus BX?
On the note, it's A plus B.
Oh, okay, doesn't matter. You must know which one. You must know which one to write. Okay? Yeah? So then you calculate. You will get AX plus B. A good point here, the GC actually gives as AX plus B, not. Whereas in the notes, we define it as A plus BX. So you must know which one is the gradient. In the GC, the A is the gradient. So you read from a GC is 1.6 plus 1.8x. Now graphically, this is what it means, right? Graphically, it means that you have 5 points, 1, 2, 3, 4, 5, and you draw a straight line. This is the best fit straight line. The equation of the straight line is 1.6 plus 1.8x. Of course, not very good sketch, but that's what it means, right? What do you want? You want the value of y when x is 3.5. That means you go to 3.5, sub into this, you get a y. You know what I'm trying to say? Alright, so no big deal. Sub in and we're done. Is that alright? Now, if you are given what is y equals to 7, you want to predict what is x. in this case, I stress again, in this case, because x is time, and hence is the independent variable, you will still use the same straight line to tell us, to find out what is the value of x. So what you are going to do is to ask yourself, this is 7, sorry. Whoa. Okay. This is 7. What is this? You know what I'm trying to say? So you will still use the same regression line to find out what is the value of x. Now, there are cases where we will do a regression line of x on y. Okay? Which we're going to find out when do we do that, x on y. Okay? Regression line of x on y. Okay? That means sometimes you do y on x, but sometimes you do x on y. Why? Now this is the data of the length and the breadth of the quail eggs. Okay, length and breadth. Length and breadth. Okay. There is actually no independent variable. Now, can I have attention, please? If you want to estimate what is the y given a particular value of x, you will still continue to regress y on x. Now, note that there is no control variable, so there is no independent variable. However, if you want to estimate the width, the x, given a particular value of y, you will have to use the regression line of x on y. Confusing? One more time, one more time. Okay, maybe what I can do is this. What I mean is this, okay? You plot. Now, what you want, if you want to find y given a value of x, you want to find y given a particular value of x. What do? You regress y on x. That means what do you want? You want to find, this is x, maybe 2.3. You want to find out what is your y. This case, you will regress y on x. And you minimize what distance? You will minimize, you draw a line such that you minimize all these vertical distance. Vertical distance. You know what I'm saying? No, if now this is the first case that we talked about earlier, right? Now if now I want to do if you want to find x given a value of y, that means you are given y, that means 3.8. What is your x? If you want to do that, you will still draw a best fit straight line. But how do you draw a best fit straight line? You will minimize the horizontal distance and you regress x on y. It's a different line, you're right. It is a different line. Because you are trying to minimize different distance, now you are trying to minimize the horizontal distance. Do you know what I'm trying to say? This is the most difficult part. Okay? Wait. So, if you want to estimate x given y, then you will find the regression line of x on y. That's what I just said just now, right? So, which means we will still draw a best fit straight line. Let's not run away from that. We'll still draw a best fit straight line, but this time we will minimize the horizontal distances such that this is a minimum. The lines will be different. Do you know what I'm trying to say? The lines will be different because you're trying to minimize different things. Get it? Now the principle is important, the how is quite standard. The how is really very standard. You are trying to now minimize the horizontal distance in order to find regression line of x on y. Okay? How do we find then? How do we find? No big deal. No big deal. Okay? You look at this formula, of course, this must be true, right? Y equals mx plus c. So we write it another way, x equals to a plus by. Okay? You can, in fact, don't really care about this, but you just need to know how do we find this y as b asterisk. That means it's the slope of the regression line of x on y, b star. Okay. Okay, let me just very quickly do a quick sketch and I show you what I mean. I'm trying my best to draw nicely, so pardon me, it will take a bit of time. It's a challenge. 1, 2, 3, 4. Let's say we have 4 points. The idea is this. If you sketch y on x, you will get a particular line. Because you want to minimize this distance, you want to minimize this distance, you want to minimize this distance, and you want to minimize this distance. If you were to sketch x on y, you may draw a different line such that it's, I don't know, like that. Marginally different, but they should intersect at one point, such that you minimize this distance, you minimize this distance, you minimize this distance, and you minimize this distance. This is x on y. Do you know what I'm saying? Now, the most important point here is the two lines will pass through this special point called x bar, y bar. Given, assume that it's shown. The two lines will pass through the point x bar, y bar. The two lines will pass through the point x bar, y bar. Now, when do you use x on y? You use x on y when, of course, y is the independent variable. But if none is the independent variable, if you want to estimate x given a value of y, then you use y on x. Okay? The third point is the one that I mentioned just now. Both lines should pass through x bar, y bar. both lines should pass through x bar, y bar. And it shouldn't be very different. Okay, the two lines here shouldn't look drastically different. They just have different slope. That's all. Slightly different. Now, this last point, r squared. Look, if you draw a regression line of y on x, you get one gradient as b. X on y, you get another gradient that's b star. This result tells you that r squared is actually equal to b times b star. You know what I'm trying to say? Yes or no? Or lost already? Give up already? Huh? Give up already? Don't give up ah. Cannot give up now ah. Okay? Cannot. Okay? Okay. Let's try this. Let's try this. Given all this data, okay, if you want to find the value of x given the value of y, can you all go through this exercise, enter this in your GC, and tell me what is the value? Okay, come, let's do this together.